Hello students, let us solve this question from TIFR 2025. So in this question, you have been given a operation amplifier circuit and now you're applying this input to the non-inverting terminal of op-amp and we want to calculate what will be the output here. So now if you apply this input to the non-inverting terminal, what will happen? Suppose this diode I will plug it out. So I will remove this diode from here and I'll see what is the voltage coming here. So when I remove this diode from here, this op-amp will come in the open loop configuration. And when open loop configuration, you're applying V input to the non-terminal. Here there is a no voltage here. That means this op-amp will go in saturation. So here saturation voltage will come and that voltage will be sufficient to make this diode conduct. That means when you are applying positive voltage here, this diode is conducting. This becomes short circuit or 0.7 volt. So ultimately now this comes in the closed loop configuration. And now in closed loop configuration, we know the virtual ground concept is applicable. That means the voltage here and here will be the same. So whatever voltage you apply, that voltage will come here and that voltage will go here and capacitor will charge up to this V input and this short circuit. That means V output is also equal to your V input. This voltage will come here. So V output is V input. So whenever you're applying voltage here, you get same output up to until it gets charged. Now what happens if you reduce the input? So when you reduce the input, what are actually doing? This voltage, now capacitor is charged, here voltage is V input, and now you are applying new V input voltage. So now this is a V input, which is equal to V output. And now you're applying V input, which is less than the V output here or V previous input. So now what will happen? This voltage is higher than become higher than this voltage. That means now this will go to the negative saturation. And when it goes to negative saturation, this diode will get open and there will be no further charging. Because now there is a open loop configuration, there will be no further charging. Now, this capacitor will maintain this voltage. So now capacitor will maintain this voltage, V output will be fixed. Again, when you V input goes higher than this V output, then what will happen? This voltage, what will happen? Again, this diode will start conducting and again the charging will happen and the voltage will go higher. Again, if you reduce, same thing, voltage will maintain and again this will happen like this. So that means you are from this circuit you can identify the peaks present in the input. So this is the first peak, this is the second peak, and this is the third peak, and you can know what are the peak voltages. That's why this circuit is called your peak detector circuit. This is your a peak detector circuit. So here this circuit identifies the positive peaks. You can design a circuit which can identify the negative peaks. So this is the solution. So this output is given as option A in the question paper. So this is the correct answer. Hope you like the solution. Thank you very much.